Today we are going to be talking about how to determine what answer to give in a division word problem when there is a remainder. So there are a few different things that you can do with the remainder or the type of answer that you will give depending on the question that is being asked. So one of the ways that you might see a question being asked is when they ask about how many complete groups or whole groups, such as if you were making necklaces and they want to know how many necklaces you can make, or how many of a product you can buy with the amount of money you have. So we often call this type of remainder ignore it. The remainder does not matter. They're asking you how many full groups there are, or you can't divide up the remainder anymore. Another type of question you might see on a division problem has to do with if they want everything included. So that might be fitting people at tables or going in cars, or you might see this as putting books or some kind of toy in shelves or boxes. And in this case, you want everything included. You don't want anything left out. And so you will round the quotient up by one full group. So sometimes we hear that called as round up, but it really means you are just taking that remainder and you're just adding another group to your quotient. Another type of situation you might see is when they just want you to report it. So that's when the question asks only for the remainder. So that this might pose as how many will be left over, how many will not fit, how many extras are there. And then, of course, when we're talking about money or food or something that can be broken up and divided into smaller parts, they might ask you to use it in your answer. So you're sharing it as a decimal or a fraction. Well, let's take a look at a couple examples and how our answers might change depending on the type of question asked. So in our first example, you will see that there is no question yet. So in this case, we just have the first part of a word problem. And this is where they're going to give us all the information we're going to need to answer the question that follows. So if we take a look at this problem, it says there were 63 people going to a football game. Each car seats 4 people. Okay, so I circled my numbers, and that's going to be, I've got the 63 represents the people, and the 4 represents how many fit in each car. So I see the word each. I'm going to box that in, because when I see that, I know that I'm going to be thinking about equal groups. Now, as I go through my process as a mathematician, I know that if I'm taking people and putting them into cars in equal groups, I am not finding a total, I am finding a part, and that part needs to be equal. So that tells me that I'm going to be dividing. But what I need to go look at now is, what is the question asking me? So if we take a look here, you'll notice there are 3 different questions here. Now, depending on the situation is going to be what part of the answer I'm going to give. So let's go ahead and solve this, and then we will, let's take a look at the questions to see how our answer might change depending on the question being asked. So we've got 63 people, and we're putting them in groups of 4 to represent each car. 4, I can make one group of 4. If I have 6, 1 times 4 is 4. That leaves me with 2 10s left over. I'm going to bring down my 3, and I can make 5 groups of 4 out of 23, which is 5 times 4 is 20. I subtract that, leaves me a remainder of 3. Okay. Now, let's go back and look at the different questions that might go along with a problem such as this. So let's say they ask us, how many cars will they need? So in this case, they're implying that everybody needs to go to the game. Nobody wants to be left at home. So these 3 people that are not fitting equally in cars still need to go, which means I need to get another car. So this is an example of rounding up by 1. So I'm going to add 1 to my total number of full cars that I had. So instead of 15 cars, I'm going to need 16 to get everybody there. Now, that last car, that 16th car, is not going to be full. It's only going to have 3 people in it. So, you know, there's room for an extra if they decide to join later. So if the question's asking how many cars, in this situation, I'm rounding up. Let's look at the next question. It says, how many people will not fit in a car? So here, it's asking who is not going to get in the car. In this case, they want just this remainder here. So we'd say, well, 3. There's going to be 3 left over. And the last possible question you could see might be, how many cars are full? So in this situation, they're not asking, they don't care about who's left over. And they don't care how many it's going to take to get everybody there. They just want to know, well, how many of the cars were full? So in this case, we made 15 equal groups of 4. So we had 15 cars full. Let's take a look at another example. So the story here says Jane and Tony earned $63 selling lemonade. So as before, I'm going to mark Jane and Tony. That is 2 people, and they earned $63 selling lemonade. Well, now let's go to the question to see what it is it wants us to do with these different numbers. Do they represent parts or the whole? So the first question we see says, how many dollars did they each get? So thinking about that, or the next question, how many dollars are left over? In the third situation, how much money did they each get? This is telling me that 63 is going to be our starting value. This is the total amount of money they made, and they're going to be sharing it between the 2 of them. So that's my part, which means I must be looking for the part that they get, which means we are yet again dividing. So again, I'm going to set up my equation, 63. This time we are making groups of 2. 2 goes into 6 3 times. 2 times 3 is 6. That leaves us no remainder. So then we're going to look at the 3. I can make 1 group of 2, which is a total of 2, and that leaves a remainder of 1. Okay, so let's go back to each of the questions to analyze what part of our quotient we are being asked to provide. So the first question says, how many dollars did they each get? Well, I notice that it says dollars, okay? It's not asking for change, because in this case, in money, I can take this leftover dollar and I can split it into 2 groups. So that would be, they would get $31 and half of another dollar each, which is 50 cents. So if they're asking for how many dollars, okay, this 50 cents, or if I'm thinking about decimals, 50 hundredths, is not representing a dollar. It's representing a part of a dollar. So in this case, they're just asking for how many whole groups. So for this problem, I would say, well, they each get $31. So I'm ignoring the remainder here. If we look at the next question that could be asked for this story, how many dollars are left over? Well, we had $1 that was left over. So I would say $1. And the final question, how much money did they each get, is implying that they want us to use that remainder. So they want to know, because I can split money up into decimal form, what is the total amount they would get. And so for this one, it's going to be $31.50. So you can see that the problem changes what we are being asked to report out on based on the question. The work we did stays the same, but what part of the answer they are looking for depends on the question being asked. And so when we're thinking about division word problems with a remainder, it becomes really important that we think about what the question wants us to give.